Good morning, Math A. We're going to do some word problems with area. So have your printed PDF or do electronically or lined piece of paper would be just fine. Here we go. Jeremy needs to buy soil for his garden in his backyard. A sketch of the plot is to the right, or kind of below. Find the area of the garden. So you can either cut up and add or surround and subtract. I like to surround and subtract. So I'm going to go the big area minus the inside rectangle. So my big area is 10 by 14, so 10 times 14. Minus my little one is 4 by 6, so minus 6 times 4. So here I get 140 minus 24. 140 minus 24 is 116 feet squared. Okay, so I got my area. Next one, how many feet of fencing? So feet of fencing. Is fencing area? Does it cover the whole yard? Or is it perimeter because it goes around the shape? So this right here, when I see fencing, I know that that's telling me that I need to do perimeter. Okay, so I know what I need to do is I need to go around the shape, start at one spot, and go around it. And I have to find what's missing. So here, I am going to assume that these two are the same. I don't really know that, but in the long run, it'll be the same amount of fencing whether it is or not. So this whole thing was 14, and this part is 6. Then together, these two parts have to be a 8. I'm going to make them 4 and 4, but they really could be a 2 and a 6. It doesn't matter. They have to add up to 8. So here we go. This is going to have to be, I'm going to make that one a 4 and that one a 4. Over here, this is going to be a 4. I look around, I need something over here, that's a 10, so across here, this is a 10 also. Now I start at one particular spot and I work my way around. So I'm going to start here at the 10. So I got 10, then 14, then 10, then 4, then 4, then 6, then 4, then 4, then back to where I started. So I'm writing those numbers out. 10 plus 14 plus 10 plus 4 plus 4 plus 6 plus 4 plus 4. I double check. There's a lot of numbers there. Count them. 1, 2, 3, 4, 5, 6, 7, 8. Do I have 8? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I'm going to add it up. I don't need to jump to my calculator. All of a sudden, I can kind of group things up. I have a bunch of 4s. So that right there is 16. Okay, I'm going to put my 10s together. That's 20. And I'm going to put my 4 and my 14 and my 6 together. That's another 20. So 20 from the 10, 20 from the 14 plus 6. I've got 16 from all those 4s. That makes it much easier to add. So altogether, I have 56 feet of fencing. Okay, so what you don't want to do is randomly go around picking numbers. Go start at one spot and go around your shape until you hit back to where you started. Again, adding, you don't have to get your calculator. You can kind of group some numbers that are easy to group together, make your adding a little easier for you. All right, let's go. Kara and Charisse are quilting competition. Both are stitching rectangular shaped quilts. So far, Kara's quilt has an area of 2,278 square inches with a length of 44. Charisse's quilt has an area of 2,276 square inches with a length of 47. Whose quilt is wider? Approximately how many inches is it wider? Round to the nearest hundredth. Okay, so we've got two people. So I'm going to organize. I have Kara. And Charisse. And I know about their areas. And I know about their lengths. And I want to figure out their widths. Okay, so y'all just read one time, figure out what is it even talking about, what do you need to organize. All right, and then I reread. First sentence is just context. Okay, second sentence, still context. Third sentence, we have some of Kira's information. We've got her area is 2,278, and we have her length is 44. Okay, next sentence, we have Sharice's area, 2,276, and we have her length is 47. All right, and now we're ready to do some math. I know that length times width equals area. Length times width equals area. So if I want to get back to the width, I'm going to have to divide. So here I'm going 2,278 divided by 44, and I get that this width is 51.77. Over here, 2,276 divided by 47, and I get this length is 48.43. Okay, so whose is wider? Well, Kara's is wider. So we'll answer that question. Kara's quilt is wider. Okay, then it says approximately how many inches is it wider? So how many inches wider? So I have to subtract. So I'm subtracting these two numbers. And when I subtract them, I get 3.34. So it is about 3.34 inches wider. Round to the nearest hundredth. Yes, I did. Okay, we're good. Next question. Rufina bought two 12-foot pieces of lumber and two 8-foot pieces of lumber to create a border for her garden. She wants to use the wood to enclose her garden. She has a saw, cut the lumber in different size lengths. So we don't have to do 12 and 8 foot. We can cut this into 4 feet or however we want to cut it. How should she use the 4 pieces to create a garden of the largest area possible? What is the largest area she can get out of the 4 pieces of wood? So we have to think, what kind of shape has the largest area? So if I have a long, skinny rectangle like this, is that going to give me a large area? Or is that going to give me just a large perimeter? Okay, if I have something more like a square, would that give me a large area? Or would that give me a smaller area? So I have to think. I want my numbers, when I multiply, to be relatively high. So something like this, 1 times something is not going to give you something a high number. But if you do a little bigger, you'll get a high number. So I have to think how much wood I really have. And then I'm trying to make something that's close to a square to get my maximum area. Okay, so first I have to know how much wood does she have? I have to figure out the perimeter. So she bought two 12-foot pieces of wood, so 12 plus 12, and two 8-foot pieces of wood, 8 plus 8. So right now I know that 12 plus 8 is 20, so 20 plus 20 is 40. We've got 40 feet of wood to work with. We want to get close to a square, and I know on a square each side is the same. So I know that 4x would equal 40, because that's perimeter. So x would have to be 10. So if my sides of my rectangle are 10 and 10, then my area is going to be 100. Okay, we're assuming we can't make a circle. If we can make a circle, it would be even better, but our pieces of wood are straight and not curved. Okay, so to maximize her area, she should build a 10 by 10 foot square that has an area of 100 square feet. Okay, so imagine if I had you with a bunch of your friends and I said, hold hands. And I said, now, with holding hands, spread as far as you can from each other. You would make a circle. But in this instance, we don't have curved pieces. So when you don't have curved pieces, then the best thing you can do is make a square. All right, number 4. A triangle has an area of 90 square centimeters. If its height is 15, what is the length of the base? That's pretty easy. We just have to work backwards on our area formula. So I first start out with my area formula. I know the area of a triangle is 1/2 base times height. Plug in my information. It said the area is 90, and it said its height is 15. Okay. So I know that half of 15 is 7.5, so 90 equals 7.5 times the base. Then I just have to divide by 7.5, and I get the base is 12 centimeters. Sketch a triangle with an area of 90 square centimeters and a height of 15, and the base you found in part A. Is there more than one triangle that you can do in those dimensions? Well, sure. I could make, I'm not making these to proportion, I could make a right triangle, or I can use the same base and make an isosceles triangle. Yeah, it doesn't matter as long as my base is 12 and my height is 15. Sometimes the height of your triangle is not one of your sides. Okay. A new triangle that has an area 150 of the original 90 square triangle. If the height remains 15, what would the new base have to be? Well, I'm going to find my new area. My new area is my old area, 90. 150% of that, so I'm going to multiply by 1.5. My new area is 135. So 135 has to equal 1/2 my base times, my base times 15. So I'm dividing 135 by 7.5. So here I get my base is 18. Next question. Julius drew a trapezoid that had a base of 15 and 11 and a height of 4. What is the area of the trapezoid that Julius drew? Okay, so I start out with my area formula. For a trapezoid, the area is equal to 1/2 the sum of the bases times the height. It told me that my bases are 15 and 11, and 4 is my height. 15 plus 11 is 26. 26 times 1/2 is 13. 13 times 4 is 52. So 52 inches squared. Can you draw a trapezoid with the same area but with different measurements? Well, as long as my bases add up to 26, I could. Okay. So here I could draw, so I just have to think of numbers that add 26, maybe 20 and 6. So I can make this 20 and this 6, and then I might draw my trapezoid, and my height would still be 4. What I have to pay attention to is that the 6 plus the 20 have to add up to the 26. So I could have done 1 and 25 or any numbers, 19 and 7. It wouldn't matter. Sketch a trapezoid with the same height but with bases that are 5/2 scale factor of the original trapezoid. Okay, so I still want a height of 4. Now I have to work on my bases. My bases were 15 and 11, but I have to multiply those by 5/2. Okay, so 15 times 5/2, that's 37.5. Again, these aren't to scale. And 11 times 5/2, that's 27.5. There we go. What is the area of the new trapezoid? Okay, so I have to add my bases. 27.5 plus 37.5 times by the height and times by a half. When I add my bases together, I get 65. I'm going to multiply the half and 4 first, so that's 2 times 65. And 65 times 2 is 130 inches squared. Moving on, number 6. Miss Garcia has a table shaped like an isosceles trapezoid. Isosceles, 2 sides are the same, so the legs of the trapezoid are the same. In her 3rd grade classroom, the 2 parallel sides have a length of 6 and 8. The distance between them is 4 feet. What is the area of the top of her table? Okay, well, she described everything you need to know about the trapezoid. So we can draw a trapezoid if you need a visual. If not, you don't have to. She said the 2 parallel sides are 6 and 8. Those are the bases. She said the distance between them, which is the height, is 4. So we have all the information we need to draw. And she said these 2 are congruent. Okay, so 1/2 base 1 plus base 2 times the height. So 1/2 of 8 plus 6 times the height, which was 4. 1/2 of 14 times 4. Half of 14 is 7. 7 times 4 is 28. So we get 28 feet squared. Suppose she has this puzzle. How much surface area is now available on our table? So we have to take the surface area we had and subtract the surface area of the puzzle. Now, we're going to assume that it's a rectangle. It doesn't say it's a rectangle, but most puzzles are rectangles, so we'll go with the fact that it's a rectangle. All right, so we're going to take the 28 minus the puzzle, 1.75 times 0.8. Okay, so 28 minus 1.4. We get 26.6 feet squared. There are 26.6 square feet left on our table. Number 7, a circular swimming pool with a diameter of 32 is located exactly in the middle of a 40 by 40 square. For safety reasons, the lot needs to have 8-foot fence on the perimeter of the entire lot. How long will the fence need to be? Okay, so let's draw it. We've got a square that's 40 by 40. And inside it, we have a pool. And the pool's diameter is 32. Okay, and we need an 8-foot high. This kind of confuses people. That's just how tall the fence is. It's 8 foot high. It doesn't mean it's long that. We have to figure out the length. We have to go around the square. So we're going 40 plus 40 plus 40 plus 40, or 40 times 4. So the perimeter is 4 times 40. She needs to buy a 160-foot fence that is 8 feet tall. If the fence was around the circular pool, how long would the fence be? So if we wanted to put it around the circle, we'd have to find the circumference of the circle. So circumference is equal to pi times diameter. And the diameter is 32. So 32 times pi. And we have to get our calculator out. I'm going to use pi as 3.14. And we get about 100.48 feet. Explain how much longer the fence around the whole yard than the fence only around the pool using percent increase. So we have to remember what percent increase is. So percent increase, we have to go the new minus the old. We have to figure out what the change in the value is. So we have to do new minus old over the original, so over the old. equals our percent over 100. Okay, so our fence 160 minus the 100.48 over the 100.48 equals x over 100. So I'm cleaning this part up. 59.52 over 100.48 equals x over 100. Then I'm going to cross multiply that, and I get x is about 59%. What percent of the yard's area does the pool take up? So now we just have to find the area of the circle. So we have to find the area of the circle over the yard. So pool over yard, because we're trying to find percent. The pool is a circle, so we have to go pi r squared over the square, which is 40 times 40. If the diameter is 32, then the radius is 16. So here we have to go pi times 16 squared over 1,600. 16 squared is 256. So I'm going 256 times pi. So I'm going to use 3.14. Then I'm going to divide by 1,600. And when I do that, I get about 0.5024. It said to the nearest percent. So that is about 50%. What percent of the yard is not taken up by the pool? Well, if 50% is taken up by the pool, then we have to subtract from 100. That means that 50% is not taken up by the pool. Okay, moving on down. Nico is building a circular deck around the circular pool in his backyard. The pool has a radius of 15, I see right there, and the deck will be about 5 feet wide. Find the area of the deck. So we have to go the big circle minus the inner circle. You have to go the big circle minus the inner circle. Okay, so if this was 15 and I added 5, then that whole area would be 20, or the whole radius would be 20. So I have to go 20 squared pi minus 15 squared pi. 20 times 20 is 400. 400 pi. 15 times 15 is 225. Combine like terms. I like to calculate my pi very last. Then I multiply by 3.14, and I get the deck's area is about 5,495. Sorry, 449.5 feet squared. If Nico adds 5-foot deck around the pool, what percent increase of space will it be? Okay, so again, we have to do percent increase. So we have to go the whole thing minus the pool over the pool equals our percent over 100. So the whole thing was 400 pi minus the pool. So we get 175 pi. That's what he added for the deck. We did that work already. So I get 175 pi over the pool. We did that already. That was a 225 pi. Equals percent over 100. Okay, my pi's are going to cancel off. Goodbye. 175 and 225 can definitely be divided by 25. So I get 7 over 9 equals x over 100. Then I'm going to cross multiply. And when I cross multiply, I get x equals 77.7 repeating. It says, it doesn't say anything, so we can leave it like that if we want. It doesn't say where to round. Okay, you're done with the lesson. Now it's time to go do your homework.